Got 2 questions to go over, and the first question is this question right here.
It was dumb. Oh yeah, I got something to show you.
It's got 4 zeros. So 0.004086. Turn that into scientific notation. We're going to move it till the decimal is where? Between the 8 and the 6. And then we're going to count 1, 2, 3, 4, 5. 8.6 times 10 to the blank 5. Which way do we move this decimal in our head to get it back the way it was? To the...
What are you talking about? To the left.
Yes, to the left. 8.6 times 10 to the negative 5th.
This is the stuff I kept on getting last.
Did you hit record?
Yes.
Okay.
Why? Are y'all okay and easily? I mean, is there anything coming out of the vents up there?
We're cracked
or what?
out. We're all cracked out.
Okay.
Just kidding.
The reason I sent that was because I kept on getting like not images, but these little notifications saying that like my answer wasn't correct, but it was the exact answer as the correct answer.
Okay, that does happen from time to time, and if it happens on a test, just let me know. See me after class, and I'll look at it. If it's the same thing, I'll give you credit for it. Sometimes that happens.
That was the reason that I even sent that up. It wasn't the test, but it was the homework.
Okay, well that is, you got a 6 right there. Did you know that? You had a 6 right there.
I had a 6?
Well, there. Did the same thing with me.
Yeah.
I don't know how to. The answer is correct. So, I have no idea why it's wrong. Anybody have any idea?
Nope.
Russia.
It's the Russians. Just say it's the Russians.
The Russians.
I'm good.
I use the X. No, that's usually, yeah, I bet that, let me try that.
Did you use the multiplication?
I'm going to use that. That's probably it, Mr. Miles.
Right.
I don't know if I can't. Hold on, let's do another one and I'll type it in using the asterisk. So that's going to be same thing, 2.1 shift 8.
Right.
10 to the negative 5. Everybody with me?
Mm-hmm.
Shift up, negative 5. Now let's see if we're right. That's it. They don't want an X. They want shift 8, which is your asterisk. Okay. We're good?
Mm-hmm.
All right, next one. And this one is a good test question. So let's see. And that's probably why you got it wrong here. You didn't put a star, but we'll see. So this one says 3 million times 280,000. So I'm going to change it to 3.0 times 10 to the 6th times 2.8 times 10 to the 5th. And then 3 times 2.8 is 5.6, isn't it? And 6 plus 5 is what? So 5.6 times 10 to the 11th. That should be your answer. Three times 8 is 6. No, 3 times 8 is 24. Sorry, I do that. I can't stand 8s. I said 3 times 8 is 16 in my head. 3 times 8 is not 16. 3 times 8 is 24. bring your 2, 3 times 2 be 8.4 times 10 to the 11th. And I think you got it wrong because you put a multiplication symbol there instead of a shift, blah, blah, blah. Let's see if this one gives us the same type question, and we'll check. This is 2 times 10 to the 5th. 2.3 times 10 to the 3rd. The 4th, that's the 4th. What's 4 plus 3? 7?
Yes, sir.
And then that's 4.6.
That's right.
Shift 8, 10, shift up to the 7. Y'all check me. I did it in my head. Check me. Miss Simmons, just let me know when you get the answer.
Sir. It requires me to take my hands out of my shirt, and I'm freezing.
I'm Hubert. Nice to meet you, Freezing.
I thought my name was Tired.
That's what you said last week. Oh, we're just going to eat in front of everybody. Okay.
Sorry. All right, I got you an answer.
What'd you get?
Wait, do you want, like, what?
Forget it. That's all right. Just
I don't know
stay
what you
back
want.
there and
Like,
keep
what-
quiet.
What form do you want?
I got it right.
Oh, good thing I didn't answer because I was about to tell him 84 billion something.
We're not even doing that one. We're doing the one right here.
Hubert, you okay today?
Just make sure nobody sees the pipe if you get stopped, okay?
It's awful. Can he say that?
Because they will get you for possession of paraphernalia.
Is he allowed to say that?
I don't know why I just want Facebook. I guess I just want to do something else. All right.
Oh, this easy.
Ooh, get that away from me. I hate algebra.
Yeah, let's just go ahead and start with a bad negative comment. That's great. All right, so I want to tell you a little story. So there's these 3 guys. They live in Clemson, and that's with a P. They live in Clemson, and they're going to travel down to South Carolina. Down to Columbia. So here they are in Clemson, and they're going to travel to South Carolina, or Columbia, University of South Carolina. And they go down there, and they get they look for a hotel, and they find an old rat hole hotel, and that rat hole hotel costs $30 a night. Okay, this is an old joke, so I just use 30 because if I change it, then it'll cause a big deal, and I don't want to do that. So $30 a night. So there's 3 guys. So each of the guys give the guy $10, right?
Mm-hmm.
Well, they go to the room and they start to settle down, get ready for the game and all. Game's the next morning or next day, so they get their refreshments and their tailgate supplies together. And the old man down in the office, he's down there with his grandson. He said, I charged those guys too much. They're right above the dumpster, and we need to knock $5 off of it. So take this $5 bill. He gives his grandson $5 to take up to the guys. And about halfway up, the grandson, he's, 6th, 7th grade, he starts thinking about that thing and says, how am I going to give 3 guys a $5 bill?
You not?
So he runs back downstairs and he gets the grandfather to give him 5 $1 bills. And he goes back up and he stops and he says, well, how am I going to give 3 guys 5 $1 bills? So he takes 2 and puts it in his pocket. Everybody with me?
Mm-hmm.
He gives each of the guys $1. So how much do they pay for the room? $9 a piece, which is what? 9 times 3 is 27, plus the 2 in his pocket. What happened to the dollar?
I know this and I can't think of it.
He started with 30. He gave them each one of the guys gave $10 a piece. Then he put 2 in his pocket and gave each one of them $1. So in essence, they paid $9 a piece for the room. 9 times 3 is 29. 27 plus the 2 in his pocket is 29. What the heck happened to the dollar?
Somebody stole it.
Somebody stole it. He bought some crack with it. He bought some meth with it.
You can't buy meth that cheap.
How you know that?
Pipehead. So somebody tell me what happened to the missing dollar.
He got it went to his vending machine.
You know, you can win all kind of beer on this.
Is it right now? What, you can win beer if you get this right?
Yeah.
You bet people they can't get it, and they can't.
He dropped. I don't know. I want to know now.
Now
you got me interested.
This is real good. I haven't said this was something good, but it is.
I can't hear her. Her mouth's full of something. I can't.
Sorry. This is good. I didn't think it was something
making
good.
us all hungry, you know.
I'm sorry.
Is it good? I hope it's good.
Get away.
There you go. It's from Shalotsky's. It has like some beans and some grilled chicken.
Sounds good.
It is. It tastes like Mexican food, like a taco.
Okay, good.
He cracks me up.
She's going to fail this class. Just mark it. I'm marking one grade. She's going to fail for evening class. Make it. She don't care. She don't care. All right. So where's the missing dollar? I need some answers.
It got stolen, or he dropped it.
There is no missing dollar.
Oh Lord, we doing the PEMDAS. The
No, I don't
PEMDAS.
understand that. What's PEMDAS? I don't understand that.
He ain't never gonna listen.
What did I do first?
You had $30.
Yeah, but what did I do first? I subtracted. And then I what? No. I subtracted, then I what? What did I do with the nines? I multiplied. I did it bass
You gotta multiply first.
You gotta multiply first, then subtract.
Yep, so it's
If you don't do the order of operations in the right order, you're not gonna get the right answer. You're gonna get a wrong answer. Okay? So, order of operations is very important. I tell students to remember order of operations like this. You got these two, and you got these two guys. When you got these two guys, they're like brother and sister. Brother and sister fuss and fight all the time. And they undo each other. Usually they're opposites. But when you have them in a mathematical sentence, you go left to what?
right.
Go left to right. Same thing with these two brothers and sisters. If you have brother and sister multiplication and division, you go left to right because they undo each other. Some examples is one like this. 2 minus 3 plus 6. Well, what's 2 minus 3? Negative 1 plus 6 is 5. But if you do 2 minus 9, you're going to get what? You're going to get negative 7. Down here, 4 divided by 2 plus 6. I'm sorry, not plus. Multiplied. What's 4 divided by 2? What's 2 times 6?
12.
But what's 2 times 6? What's 12? 4 divided by 12?
3.
No, it's not. It's 1/3. So you get 2 different answers. If you have a mathematical sentence and you just have these 2 in any order, or these 2 in any order, you go left to what? Right. If you have a crisscross of brother and sisters, you have cousins. This is a Hubertism. You're not going to see this in any book. In fact, my boss started using this. If you have cousins, you go to where? I can't spell. You go to Aunt Sally's house. Or you go PEMDAS. Please excuse my dear Aunt Sally. I told you about the PEMDAS girl, didn't I? I don't understand that, Mr. McClure. I was learning. I was always told PEMDAS. Shut the hell up.
What'd you tell her when she said that?
I just looked at her like, you're a pain in the ass. That's what I looked at her like. I didn't say nothing. That's why I'm divorced, because I can't handle people like that. All right, brother and sister, you go left to right. Cousins, you go to Aunt Sally's house. Now that's a review. Most of you should know that. But you can't do this. This right here does not work 100% of the time. It works about what? 90% of the time. Because sometimes you will have a question on a test, and it is nothing but brother and sister. You go left to right. Does everybody understand that?
Yes, sir.
Okay. I just want to make sure, because we got to understand that before we get into algebra, because we're going to do 2 things in algebra, and that is evaluate and determine. So I might as well go ahead and write those down. So some of y'all that this is review, what does determine and evaluate mean?
Is evaluate like working a polynomial?
Kind of, yes.
Means to find the answer.
And determine.
Those 2 words in 25-cent layman's terms plug and what?
Chug.
When you see evaluate or determine, that means you're going to plug in a number for X, and you're going to plug a number for Y, and you're going to do the math. So whenever you see those 2 words, it's holding your pinky up words for plug and chug. Now, with those, I'm going to go into the handy-dandy, this part. I'm going to go back one. No. Now, write those down. I mean, you don't have to write it word for word. Algebra is the form of mathematics that undoes basic math. Where you learned back a long time ago 2 plus 3 is equal to 5, we're going to undo that and say 5 is equal to 2 plus what? X. X is called a variable. In statistics, it's called a statistic or a parameter. But in algebra, it's called a variable. A variable is an unknown letter. that represents the number you are trying to find, which is also called the solution. A constant is a number. Like if I give you 5x, 5 is a constant. It's also called a coefficient. A lot of this is very, very, very basic, and a lot of it is very, very, very review. Okay, I know that. I don't want to spend a lot of time on it because I don't want to insult your intelligence. Okay. Now, I will spend a little bit of time on this because a lot of people don't understand the difference between an expression and an equation. An expression does not have a what? Equal sign.
Equal sign.
Therefore, you cannot solve it. You simplify it. So write that down. You do not solve an expression. You simplify it. So I want you to write in big A words in red. Simplify. Because it does not have an equal sign. Now, there's not really, you can't do much to simplify these expressions, but here's an expression you can simplify. X to the fourth divided by x to the second. X to the second is your answer. You subtract exponents. So I just simplified that answer. Another thing you can simplify. What's 2 over 4?
1/2.
1/2. I just simplified it. I just reduced it. Okay, simplification is nothing but reducing. Rewriting is different from simplification. Here's an example of rewriting or factoring. If I take this and rewrite like that, I have rewritten it. Have I simplified it? No. I have rewritten it into its factors. Again, this is kind of a review, so just take it in stride. Terms are each part of those things. That's a term. 4x is a term. 3y is a term. And 5 is a term. Coefficient is a 4. So you might want to highlight that 4. It's called a coefficient. Some of you may remember this from like pre-algebra or algebra 1. Five is a constant because it doesn't have, actually it does have a variable. You can make it any variable you want to the 0 power. So I'd make it w to the 0 power. Because w to the 0 power, x to the 0 power is what? 1. So you could put any variable you want to as long as you put it to the 0 power. But it's considered a constant because it does not have a variable. Like terms, unlike terms. Well, that's self-explanatory. Okay. I want to go to the whiteboard here. I want to get off of these right quick because I want to go to the whiteboard. I want to go over a couple of things because most people, and I'm trying to skip over some stuff for y'all. 90% of you know how to do, or 99% of you know how to do these following things. I don't know why this thing won't switch. I've hit it 5 or 6 times. X plus 4 is equal to 6. X minus 7 is equal to 12. 4x is equal to 16, and x over 7 is equal to 2. All of these are what we call equations. Equations are not simplified, they are what?
Solved.
Solved. Because they have a what?
Equal sign.
An equal sign. Now, back in pre-algebra, you were taught how to do these, and there wasn't a problem because most people can do these without any problem whatsoever. You've probably already done them right now in your head, and that's fine. But as I told you with scientific notation, that's not the problem. The problem is when you start adding things to them. Okay? So what we're going to do is we're going to take each step, and we're going to work through these equations, and we're going to take off everything we need to take off and put it in or whatever in steps, so therefore you won't be confused. All right? We know here, how do you get rid of them? Our primary objective is to get the variable by its what? Variable by itself. That's our primary objective. So I've got to get rid of a positive 4. The way that you get rid of $4 is you spend $4. If you do it on one side, you got to do it on the other. And x is equal to 2. Plug it back in to check it. How do you get rid of owing $7? You pay $7. If you pay it on one side, you got to pay it on the other. X is equal to 19. Plug it in to check. 19 minus 7 is 12. How do you end up undoing multiplication? You divide. If you divide by 4 on one side, you've got to divide by 4 on the other. X is equal to 4. 4 times 4 is 16. Check it. How do you undo dividing by 7? Multiply by 7. If you do it on one side, you do it on the other. X is equal to 14. And like I said, 99% of you probably either already did those in your head and there's no problem. Where is the problem? Well, I'm going to write down 4 things and then you're going to say, oh yeah, that's a problem. Oh yeah, I'll hate those. Okay? 1. CLT. Not BLT. Okay? CLT. Combining like terms. 2. Distributive law. 3. Clearing fractions. 4. Clearing decimals. And then 5, MIX, meaning a mixture of all of those things. That's where y'all suck at it. Okay? And when I mean y'all, I mean students in general. So, the first thing you got to do is learn how to combine like terms. And a lot of you say, well, I know how to do that. Yeah, that's fine. Sometimes I'll find out that you don't know how to do it. Okay? Combining like terms is like labels on cans or going to the grocery store. If the label is the same, you can consider them the same and you count them. 1 box of cereal plus 3 boxes of cereal equals 4 boxes of cereal. 1 can of beans plus 2 cans of beans equals 3 cans of beans. If I have 5 cans of tomatoes and I subtract 2 cans of tomatoes, I have 3 cans of tomatoes left. The label does not change. The only thing that changes is the coefficient. So if I give you 4x plus 3x, and you tell me the answer to that is what? 7x. The label does not change. Now that's with combining like terms. Combining like terms means addition and what? Of terms. It does not mean multiplication. Combining is addition and subtraction. Distributive law. We'll get into that in just a second. I want to go ahead and give you an example and let's see if you can do it. 2x minus 3x plus 7 is equal to 4x minus 2. All right, that is an example of combining like terms. Go ahead and work that problem. If you can't work it, consider yourself a disappointment. And no, you do not need a calculator, Miss Simmons.
I'm not using a calculator.
I guarantee you
Okay.
probably were going to reach for it.
No, I don't need a calculator because
Are you
I'm just that
confident?
smart. I'm
Are
just
you
that
confident?
smart. Yes.
I saw somebody walking across the parking lot this morning with a jug of water, milk jug. I don't understand these people. And he was walking around like he just come out of the gym, all bowed up. I was like, man, get in the car. Gotta love that testosterone. Dumbass. So, 2x minus 3x is negative 1x. Now I'm going to show you a trick I learned in the war. Plus 7 is equal to 4x minus 2. If I hired you to work on the farm, and I told you that I had one job for you to do, and that job is to feed all the animals on the farm, and I gave you this big old, in this room, there's this big old, what they call a corn crib, and it's full of feed. And you got your choice of a 5-gallon bucket or a 15-gallon bucket to feed the cows and horses and pigs and all with. Which one would you choose? Would you pick the 5-gallon bucket or the 15-gallon bucket?
15.
No, hell you wouldn't. You
Why
pick the
wouldn't you?
5-gallon bucket.
Getting four
Why?
done.
Have you
Because
ever
it's
tried to
not
carry
as
a
heavy.
15-gallon bucket full of sweet feed?
It's heavy.
No.
It comes up to about your hip.
Ooh, I be leaning over.
No, how would you pick it up to get it in the trough?
You get a
Okay.
tractor.
Most people, that are not gifted and talented, most people would pick the 5-gallon bucket, all right? Because it's easy to handle, okay? What does that mean? You always go with the smallest bucket. So which one's smaller? The negative 1x or the 4x? So I'm going to move the smallest bucket over to the other side. Why am I doing that? Because I want to keep the variable what?
Positive.
Whenever you're using combining like terms, try to keep the variable positive. Now, I always get this student that goes, oh, I can't do that. My second grade teacher told me I always got to keep the variables on the left-hand side. Well, your second grade teacher was an idiot, okay?
Yeah. I haven't got it, but.
Let me tell you something.
Yeah.
You ever taken your kids to the park, or your grandkids, or your aunt and uncle kids, or whatever, to the park?
Every single time.
Is everybody listening? And you
How's
put the
taking your
boy
kids-
on the left-hand side, and you put the girl on the right-hand side of the seesaw. Now, around here, we call them seesaws. But I was told by some of those perfect people that don't live around here that it's called a teeter-totter. Okay? So we're ignorant Southerners. We call it a seesaw. But I was corrected, and it's called a teeter-totter. Anyway, you put your kid, you put the one on the left and the one on the right. And that's it. Let's say you're in Seneca. Okay? And you put the kid on the left, the boy on the left, and the kid and the daughter on the right. Then you go to Anderson Civic Center park, and Jody, the son, or the male, or boy, whatever you call him, he wants to get on the other side. He wants to get on the right-hand side. And you say, no, you can't do that because you have to be on the left-hand side. What kind of sense does that make? Huh? Telling a student that they have to put a variable on the left or the right-hand side is stupid.
Because you get the same answer.
Thank you. Okay? So, if you were told that, you need to go back and punch your teacher in the face. I'm sorry, that's a joke. Okay. What you need to do is have some refreshments at the Mexican restaurant and tell your teacher that they were a terrible teacher and you based your profession on that one teacher. Okay. So, I got, bring that x over. What's 4x plus 1x? And that's 5x minus 2 is equal to 7. Now, a lot of students say, well, Hubert, what about the numbers? You don't care about the numbers. What's your main objective of algebra?
Solve for
What's the main objective? To get the variable by its what?
self.
By
You
itself.
could care less about the numbers. You focus on the variable. Okay, so what do you do with that 2?
You add it to the 7.
You add it to the 7, you get 9. 5x is equal to 9. Divide by 5, divide by 5, x is equal to 9/5. Now, if you will try to keep that variable positive, and you can do it about 98% of the time, okay? If you keep that variable positive, when you get to inequalities in 5.5 or 5.4, whichever is the second to the last section, when we get to that section, you won't have to memorize 2 more rules. Now, you got 2 options. You can do it my way, the way that I'm showing you, and forget the 2 other rules, or you can memorize 2 other rules, whichever ones you want to do. So I try to keep the variable positive. And if you keep the variable positive, you won't have to worry those 2 other rules in 5.5 or 5.6, whatever, or whatever chapter we're on, okay? All right, so that's how you do combining like terms. Try to keep that variable positive. Now, let's look at distributive law. How many of you have ever worked with concrete before? Let's say that you live in Florida and you can't dig a hole for your mailbox, so you got to make a cement slab for your mailbox because you can't dig a hole, you might kill a turtle. It's okay to kill, but shut up, Hubert. Okay? So you make a box and you do 1 foot by 4 foot by 4 foot. Everybody with me? Mm-hmm. And you're going to put the post in like this, and then there's the mailbox, and you know, that's how you do your mailbox in Florida because you can't dig
You're
a
a
hole.
good artist.
Shut
You
up.
really can draw.
Shut up. Anyway, she's being a smart ass. You know that, don't you?
I wasn't. I thought that was
Yes,
a
you
very
are.
good
Yes, you are,
student
because I
class.
suck at drawing. All right. So you put your concrete in there and you're mixing it and you're getting it smooth and everything. You lose your ring and it's in the concrete. And if you're a guy, you don't notice it until like 3 days later. Okay? If you're a woman, you notice it like the second it comes off your finger. But anyway, there's the ring, and for a guy, he don't notice it until 3 days later. How long does it take concrete to cure? Anybody know?
No, sir.
1 second.
24 hours it takes concrete to cure. A lot of people say dry, cure, whatever you want to say. So after 2 days, you finally figured out that your ring is in that concrete. Tell me how you're going to get that ring out of the concrete.
Got a
You're going to get a big A hammer. And you're going to what?
And you're going to
You're gonna
bust
hit
him
this
like
Pound
concrete until you find that ring. So, your
I know.
objective is to get the what? Get the ring. What's the obstacle? The obstacle is the concrete. And what is the tool?
The hammer.
The BA hammer. What the hell does this have to do with algebra? The distributive law, 2 times x plus 4 is equal to 7. Guess what this is?
Distribution.
What's it shaped like? A block.
What?
What is the objective?
The 7, maybe? The ring? No,
Just
the
the
X.
objective for algebra.
I'm just an idiot, I know. I'm just
Okay.
dumb.
No, I'm just
No,
doing it like
I,
this way I do it every semester. I get the same answers every semester. All right? And what is the 2? The 2 is the BA what?
Hammer. Hammer.
And what am I going to do with that 2?
You gonna bust it open.
I'm going to bust up that block, that green block, I'm going to bust it up. And the way that you do that is with the distributive law. Now, I realize some of y'all invented the distributive law and y'all invented algebra, okay? I know that some of y'all know this stuff, but there are some people that don't, okay? So you just play with your phone or whatever. 2x plus what? 8 is equal to what? 7. Now, how do I get rid of plus 8?
Subtract.
Minus 8. Minus 8. You get 2x is equal to negative 1. What time is it, Ladler?
1:10, we got 5 minutes.
Okay. And that's the distributive law. Now, what happens if I have a negative in front of it? Changes what? Everything. What's a negative 2 times x?
Negative 2x
And what's negative 2 times negative 4?
plus 8.
Positive 8.
Positive 8.
And it changes everything. I'm going to bring that 2x over. 8 is equal to 8 plus 2x. Minus 8, 0. Okay, is 5 minutes gone or what? Because somebody's packing up. And I still got, how many minutes I got? Look on your phone.
About 4.
4 minutes. So 0 is x is equal to 0. Now, that's the distributive law. Of course, I could give you another problem, but I don't want y'all to explode. Okay, so we're just going to go ahead and call it a day. But I don't want you to do any homework on 7 yet. Or what chapter are we on? 6? All right. I don't want you to do any homework yet. So take the night off. You don't have to do, if you finish your homework and your test tonight, right?
Right.
Okay. Just work on that. Don't do any new homework yet because I don't want to do this first section until I finish covering everything, okay? So y'all have a good day and I'll see y'all Wednesday. Okay? You too, Miss Simmons.